So a college admissions counselor was interested in finding out how well high school grade point averages predict first-year college GPA. So the jump output is given below. So we know, are the conditions met? So there are 4 conditions we want to check. First we want to see, is the relationship linear? So we want to look at their scatter plot. And so it looks like there's a fairly linear relationship between high school GPA and first-year GPA, so that condition's met. The second one says, no, the data aren't linear. Well, we just said that the relationship isn't linear. Well, we said that it is. So this condition's also met because it's asking basically the same thing. D wants to know, no, the residuals aren't independent. So what we want to check for is we want to look at our scatter plot and look like there's any sort of curving pattern in it. And it doesn't really look like there's much of a pattern here. So D is answered. E says, no, the residuals aren't uniform. This is not a condition at all. What we want to look for is, are the residuals normal? So if we look at our histogram, it kind of looks like that. That's not normal. And then if we look at our normal probability plot, it kind of has this curving pattern in it, which is also bad. So we're going to say that the residuals aren't normal. So not all of the conditions have been met. So we want to interpret our slope. So it tells us our slope is right here. So this is B1, and that's going to be 1.547. So how we interpret our slope is that for every 1 unit increase in x, we expect y to get bigger by whatever our slope is, since our slope is positive. So A says for every 1 point increase in high school GPA, this is our explanatory variable, first year GPA increases by 1.54 points, which is exactly what we want to say. B says for every 1.54 increase in high school GPA, first year GPA increases by 1 point. They have these two backwards. If we switch these two around, then it'd be correct. But since they have them backwards, it's incorrect. C says for every 1 point increase in high school GPA, first year GPA increases by 2.49 points. So they ended up using the slope of the intercept and not the slope. So this is B0. So C and D both use the intercept and not the slope. 25 says, what are the hypotheses for conducting a hypothesis test of the slope? So our hypothesis test is always going to be about the parameter beta 1, because this is our slope. So we can rule out A and B. And then C and D, where our alternative hypothesis is always going to be equal to, not equal to. So that rules out C. So the correct answer then would be D. And then what conclusion can be made from the linear regression t-test on the slope? So if we look, we have a p-value that's really, really small. It's less than 0.0001. So since our p-value is really, really small, that means we want to reject our null hypothesis. So if we reject our null hypothesis, we're going to say there is strong evidence. So we can rule out C and D. So A says there is strong evidence against the null hypothesis. We reject the null and conclude that there is a linear relationship between high school GPA and first year GPA. B says there is strong evidence against the null hypothesis. We reject the null and conclude that there is not a linear relationship. So our null hypothesis says no linear relationship. Our alternative hypothesis says yes, there is a linear relationship. So since we're rejecting the null, we're going to conclude whatever the alternative says, and that's that there is a linear relationship between the two.